Welcome to T3, Day 16 of Calculus. Today we're going to talk about the antiderivatives of exponential functions. And I'm just going to give you a nice present. If f of x is a to the x, where a is a constant, so like 7 or 8 or 12 or e or pi, what is f prime? F prime is going to be equal to the natural log of a times a to the x. So we might have mentioned this before, I think we have, but if not, we need to remember that the derivative of a to the x, when a is a constant, is ln a to the x. So what does that mean happens when you integrate, when you go the other direction with a to the x? So what's the integral, the indefinite integral of a to the x? Well, you'll notice that when you take the derivative of a to the x stays there and it just kicks out this constant ln a. So if it kicks out that constant and we don't want it to be there, it's therefore we need to get rid of it, so we place the ln a 1 in the denominator here and just put the a to the x right here plus c. Because if we take the derivative of this, we end up here, but then this ln a will cancel with that ln a, leaving us with just a to the x. Try this out. Given this right here, do this derivative, do the derivative of that. The derivative of this, I'm adding so much color here, should be a to the x. Test it out. There it is. But you need to remember that right there. So keeping those formulas in mind, let's look at this. What is going to be the antiderivative of e to the x? Well, we need to use this formula right here. And it tells us it's going to be 1 over ln, what's the constant? E times e to the x plus c. But what is ln e? That's 1. So it's 1 over 1 e to the x plus c. So the integral of e to the x is e to the x plus c. And you also should kind of see that because the derivative of e to the x is e to the x. What happens here? The only difference is that 5, and you might remember you can just factor out the 5. So this is the same as 5 times the integral of e to the x dx. Well, we just figured out that the integral of e to the x is e to the x plus c. So this is just going to be 5 e to the x plus c. What about here? Oh, same thing. You bring the 7 out, so this is going to be 7, the integral of 4 to the x dx. So it's going to be 7 times 1 over ln 4 to the x plus c. And you might wonder, can you distribute this there? Just become 7c. You can make the c 7c or c. It doesn't really matter, as long as you have a constant there. What about this one? Well, we know that the antiderivative of x squared is 1/3 x cubed. This is a constant, so it's going to be pi squared times x. And what's the antiderivative of 5 to the x? Well, it's going to be 1 over ln 5 to the x, and then you add the plus c. Okay, so when we ask for exact, this means you're not using your calculator. You need to do this out by hand. What does this look like? Well, 2 to the x minus 4. 2 to the x minus 4, you can plug in a few values and get an idea of what this looks like. It's going to look like this. This right here is 2 to the x minus 4. Find the exact area between the curve y equals 2 to the x minus 4 from 0 to 6. So we're going to say between the curve and the x-axis. So we got to go from here to here. It's going to hit 0, and then it's going to change, which is the upper function. So we have to do the integral from here from 0 to whatever that intersection is. When does 2 to the x minus 4 equal 0? Well, that's when 2 to the x is equal to 4, so that's when x is equal to 2. So from here to here, what's the upper function? 0 is the upper function. So we're going from 0 to 2 of 0 minus 2 to the x minus 4. And then we're adding 2 to 6, adding it 2 to 6. The integral from 2 to 6 of now 2 to the x minus 4 is up top. So 2 to the x minus 4 dx is on top. So now you need to integrate and plug in the values. You need to do both of these things by hand. So you'll notice here I just ended up factoring out the negative. That kind of makes it easier. And then down here, let's actually do the integral here. So we know the integral is going to be 1 over ln 2 times 2 to the x minus 4x. And we're doing that from 2 to 6. And on this one, we're doing the exact same thing, but it's the opposite. So it's going to be minus 1 over ln 2 to the x minus 4x from 0 to 2. We're just flipping it. And we flip it because it was below the x-axis here. And we're doing total area. We want the exact area. So if we keep on doing this out, we end up with that on the bottom one. You can simplify it up, but that is the exact answer. You can simplify it a little bit more. Over here, you just have to be careful with that negative. What's it going to be? Put 2 up there, so it's 2 squared over ln 2 minus 4 times 2. And then what are you subtracting? Plugging in 0 here. 1 over ln 2 times 2 to the 0 minus 4 times 0, like this. So you would want to simplify this, keeping in mind that negative sign right there, and simplify this. But these would be the exact answers, It's a lot to take in, but if you do it carefully, step by step, it's relatively straightforward. The key thing to realize here is with this graph, that right there is the upper function for the first thing to 2, and then it changes to